My name is Marcy Sutton. I am a senior front-end engineer at DQ Systems, where we work only on accessibility. Our company motto is digital equality. That's what we strive for, and so it's really cool getting to come here and tell you guys all about accessibility. You can find my slides online. It's at bit.ly/a11y-and-ci. So, a bit about my background. I work on the axe core team, and you'll hear all about axe core later in this talk about what that's about. But essentially, we work on accessibility tools for developers to meet you where you're at, to help you get a leg up with accessibility testing, so you don't have to be the expert. I co-run the Accessibility Seattle meetup. That's a bit of a new thing that I'm really excited about. So we have some events in Seattle. There's also accessibility meetups all over the country and all over the world. So wherever you live, you could look into finding a local meetup. Those are great. I have an accessibility course on egghead.io that you could check out. It's got some little bite-sized videos of how to develop accessible user interfaces. And then in the past, I have co-led the Seattle chapter of Girl Develop It, which is a nonprofit encouraging women in software. And they're currently looking for new leadership, so if you're from Seattle, a little plug for that group. I'm also hoping to start a chapter where I live in Bellingham, Washington. I have a blog that you could check out called Accessibility Wins. It's a11ywins.tumblr.com, and the goal of this website is to highlight the good, to celebrate the wins so that accessibility can be held up as something that's awesome and wonderful instead of the traditional wag of the finger that I experienced early in my career. And so if you've written something that you're proud of, send it to me so I can give you some kudos and you can share it with your team, because it's really great to get some praise for something that you may have worked really hard on. So I want to go back to earlier in my career when I worked at an agency and I kept seeing broken code go out the door. And I leaned over to my coworker and I said, "Do we do any software testing?" And he went, "Nah." And it didn't seem like something that they were going to pursue, but I just had these questions about software testing. I thought there had to be a better way. Because imagine you've been working on a redesign and you flip the switch when you go to deploy it, and if you hadn't considered accessibility at all, you could be making your website completely unusable to 15 to 20% of users with disabilities. Just all of a sudden, if you haven't thought about it, that's a huge number of people who can't access your application. So if you're new to web accessibility, the whole idea is that people with disabilities, along with everyone else, can interact with the web and they can contribute to the web. So people can use tools, they can take online education courses, you can get jobs. So the internet and technology is a great equalizer, and we all have a role to play in making the web more accessible. So this idea of pushing out new code, if you haven't thoroughly tested it for accessibility, you could be one bad deployment away from something really terrible for your users. And I have an animated GIF of a car merging onto the highway and it just goes haywire. So software testing is a way to try and anticipate some of those problems and get some peace of mind so that when you're pushing your code out there, you're not having these horrible merge conflicts. And as I've learned more about software testing and code and how those things relate together, it's sort of a meta concept to me, and it made me think of Seinfeld with Kramer's coffee table book of coffee tables, because you're writing the code and then writing the test, and the test is asserting the code, and just that relationship I thought that was a winning strategy, and I got to, hopefully, I want to go watch some more Seinfeld episodes now. So today, we're going to talk about software quality and how you can use craftsmanship and pragmatism to make better software that works for more people. We'll talk about continuous integration, what that is, how we can work accessibility into that. Before we even get to that, though, we are going to talk about automating accessibility. So what can you automate? What can't you automate? Where are the limits of that? But where can we get some easy wins to get accessibility into our workflow? And then hopefully by the end of this, if you haven't already got on board with the idea of accessibility, is that you can use technology for good. You can really enable richer lifestyles for people who need independence and privacy and safety. So accessibility as a civil right is a really important topic that I hope I can win over your hearts and minds today. So some people might be like, this accessibility thing. I mean, obviously you're all here, so we can talk about why this is great. But hopefully we can also win over our colleagues and our coworkers and geek out over it, because accessibility is super cool. And the challenges that you can solve with design and development have such human potential that I totally geek out over it, and I hope you will too. If we look at the types of software testing, there's functional testing and non-functional testing. On the functional testing side, you could start with unit tests, and we'll talk a little bit more about unit and integration tests in detail. But along with system testing and acceptance testing, that sort of fits in this realm of functional tests. On the non-functional testing side, you have things like performance, security, usability, which kind of gets back to accessibility, and compatibility testing. So there's all different strategies and ways that you can ensure software quality. We're going to focus mainly on unit and integration testing today. So the part of that, the unit and integration testing slice that we can look at for accessibility, to me, is the cool stuff. There's certain things that we can automate, including HTML and ARIA validation. So making sure that your markup is semantic, you've used things properly, we can automate the checking of that. Things like form labels, to make sure those work with screen readers. Color contrast, to look at the foreground and background colors of an element. Accessible naming, if say you had an icon button component or something and you wanted to ensure that text had been flowed into that correctly. Focus management, you could write some tests in your application to assert that focus is sent around the app. And if you saw my keynote yesterday, Blackboard does that really well. And you bet they've got tests for focus management. And then things like specifying a language. On the manual testing side, we have to do more manual checks for things like focus order to make sure it's logical. Text alternative quality, making sure that an alt text or an alt attribute is correctly identifying the right person. That's a bit difficult to automate right now. Screen reader testing. At this time, we can't really programmatically fire up a screen reader and then assert that it's doing the right thing, so that's more manual. Keyboard support for things that aren't yet keyboard accessible. It's like if it's not accessible to the keyboard, you can't really automate the accessibility of it. And then with contrast, we can check foreground and background, but if the text is over an image or a gradient, that can be really challenging because which color is it over? Big questions there. And then quality of error identification. So if you have a form and it throws up some error labels or error states, are those actually useful? So that's something that a human would have to go in and check. And in my slides, I have some resources to more on this sort of thing. But the goal of accessibility testing, it's a technical topic, which is cool, but we can't lose sight of the people who are affected. Because ultimately, that's the entire goal of writing software, is writing software for people to use. At least that's the realm I'm in. So there's people with visual disabilities, people who are blind from birth or have degenerative vision loss, color blindness, they might need a screen reader or high contrast mode. There's all different visual impairments. People with hearing disabilities who are born deaf or might have hearing loss. Maybe you listen to loud music too often like I do. People with motor disabilities who can't use a mouse. Maybe you are in a wheelchair. Maybe you use a switch control or something like that. People with cognitive disabilities, so people with autism, learning disabilities, traumatic brain injury, and there's lots of people who fit into multiple buckets, but there's so many different types of people in the world that I think it's really cool that with accessibility, we can actually make people's lives better. So getting back to being able to automate and check your work. You may have heard of the Web Content Accessibility Guidelines. It's currently, version 2.1 is getting feedback right now, but the idea is that you have conformance criteria that you can actually go and check your work to say, is this accessible, and what's the success criteria? How do we measure whether we did this right? And WCAG is the global standard for that. It's used all over the world, increasingly in more countries. And so this is the kind of the standard for checking your work of whether it was done right. So for things that we can automate, kind of basing that on WCAG or depending on your rule set, you can automate roughly 30 to 50% of accessibility issues. And that's full of easy wins, things like missing alt text or you didn't label your forms. And so there's a big opportunity to automate the stuff that we want to free up a human to not have to check that. You can save that time for these more complex things like error states, quality of text alternatives and things. And related to this is there's two really interesting groups at the W3C right now trying to standardize this piece of work in accessibility. There's the AutoWCAG community group and the Accessibility Conformance Testing Task Force, the ACT. And my colleague Wilco Fears is the co-chair of both of those groups. So we care very deeply about the standard side of accessibility testing so that we're not all reinventing the wheel over and over. But it's worth mentioning again that automated testing is no substitute for manual tests and real user feedback, including people with disabilities. It's really helpful to see how someone uses your application because that's something that's unique to your organization. A framework might have their own set of tests and their own usability feedback, but how you've implemented that together, or how your design patterns look on your site, getting real feedback from users is just so important. So I really want to stress adding that. So for accessibility unit tests, those are good for things like component-specific behavior. So especially if maybe you're building a UI framework or some components that might get reused, that individual component should have some unit test coverage, and that can include accessibility tests. If there's interaction that happens in a component or in this unit, you could write a unit test that any APIs related to focus or user interactions, you could cover those with unit tests. You could test for text alternatives. So say you had an icon button component, and when a developer uses that component and maybe you have an attribute on it for the text, you'd probably have a unit test to assert that that text actually made it into the right place. Because if it's a form control, you might need to actually expose the text. It's what's called accessible name calculation. And so if you're writing components, you want to make sure that all of those APIs are working correctly. Maybe you have some custom components that have ARIA, the Accessible Rich Internet Applications, which is a way to specify accessibility information in your application. Now, you should only reach for ARIA after you've exhausted all native HTML elements first. But if you are doing more custom controls, more complex interactions, you could write unit tests to assert that the ARIA states you're using are being turned on and off at the right time. So here's an example of a unit test for accessibility. David Clark has some great React components that are built with accessibility in mind, including the React ARIA menu button. And in his unit test, rather than asserting so one way you could test focus would be to open the component, in this case a menu, and then assert that the active element is the focused one. Well, for his unit test, he actually has an API that's called a focus manager. And so he has some tests to assert that his focus manager is working correctly, since it's sort of a side effect of this focus stuff working correctly. Now, you'd probably add additional tests to make sure that that's all working in application. So a unit test is a smaller unit, probably running in a headless browser like Phantom.js or headless Chrome. But then there's a lot of opportunity with integration tests or end-to-end, and those are good for real-world browser testing. So firing up a browser with something like Selenium WebDriver, which is a real browser, which browser you open is up to you. But that can eliminate some of the edge cases you might get with things like Phantom.js, where you're chasing down bugs purely because of your test harness. So there's some opportunity with real browsers. For accessibility, that's good for checking document level issues. Things like, is the page title correct? Is the lang on the HTML document correct? And things that affect the overall page. You could write integration tests to make sure that if you had multiple components, that when they all got put together, that they're operating correctly. So maybe checking that focus was sent from one component to another. That goes outside of the scope of a unit test. That's multiple things together, so that would be more integration test. It's good for color contrast because you have a real browser, you have everything in place at one time, so you can just check color contrast when the whole page is rendered instead of every individual component. And then if you're working in a JavaScript framework, and perhaps it's a really new framework and they don't have really good test utilities for unit tests, this is sort of a good catch-all to use Selenium WebDriver to still test for accessibility, even if those utilities aren't mature enough for you. And I bring this up because this happened with Angular 2. And when Angular 2 came out, they were really iterating fast on the framework. And so the test team, it took a while for those test utilities to sort of stabilize and become usable. So the Material 2 team, Material is a framework built with Angular 2. Rather than not writing any tests or not writing any accessibility tests, they use Protractor, which is a layer on top of Selenium WebDriver to assert that their application and components were doing what they expected. And what I like about this is that their tests have accessibility just worked right in. It's not bolted on, it's integrated. So they test really basic things like it should open a dialog. It should close by clicking on the backdrop. It should close by pressing escape, which is an accessibility test. It should close by pressing escape when the first tabbable element has lost focus. It should close by clicking on the close button. It should focus the first focusable element. So you can look through all of these test cases and see that they had really integrated accessibility into their normal end-to-end tests. And so I think that's really cool. So let's see if I have any network. I have some really funny GIFs in here, and I would be really sad if they didn't load. Maybe I can shortcut. Bummer. Conference Wi-Fi let me down. Dang, okay, well, I'm not gonna wait. So there's some really funny GIFs in here, so you should go and get my slides. But the idea is that there's some really funny animations and of real life experiences where in the offline world, they didn't do integration tests. And so that's really sad that the network didn't work. But maybe we'll get more time for questions at the end, so that'll be cool. So if you're writing tests and you're trying to decide whether to include unit tests or integration tests or like how much test coverage, I guess my number one recommendation would be to write a combination. Because you need to make sure that if you only had unit test coverage and you didn't test everything together, you would get these situations where things just don't work all put together. Whereas integration tests can be slower, they might take more time to execute, and so you kind of need a combination to make sure you're covering all of these cases. Unit tests are great because they're fast, but again, they have holes. Like if you only unit test, you'll get the hilarious scenarios that sadly we didn't get to look at in my GIFs. So there was a great article from Victor Savkin about ways to test Angular 2 components, and he pointed out different styles of testing, starting with isolated testing, which has no rendering at all, and you've mocked all dependencies, so it's just this tiny unit, it doesn't reach out to the network, anything like that. He talked about shallow testing and integration testing and sort of these different areas that you can test your application. In addition to shallow testing, there's also full DOM rendering. And if you've worked with React, this might start to sound familiar. The shallow versus full rendered DOM. So what is that? Well, essentially, there's different advantages to either having it rendered in the DOM and attached and in a real browser versus this in-memory representation, like a shallow thing, where that might work for some APIs. But for accessibility testing, that doesn't always work. So I have a table on the screen to sort of highlight what works most of the time. So if you're testing keyboard focus, like the active element, which element is focused, or does it have a focus state? that has to be both rendered and attached in the DOM. There's really no way around that. For labeling, if you have a component, you might be able to get away with that in memory. If it's like a unit test for a single component, you won't necessarily need DOM APIs for that. You might be able to get away with no rendering or no attachment. For ARIA attributes, it really depends. It depends which ARIA attributes, if it depends on children, if it depends on DOM APIs. So that's kind of a depends scenario. For end-to-end tests, we absolutely need color contrast tests to be both rendered and attached, especially for ours in aXe-Core, which I'll tell you about in a minute. We rely on DOM API methods, so there's no way around that, really. And then event handlers, that also sort of depends on your framework. Maybe your framework stubs all of these event APIs and you can kind of get around it in some shallow rendering. In end-to-end land, it really helps to have it be rendered and attached, but not necessarily all the time. And then outside of unit and end-to-end tests, because this applies to both, if you're using an API to test for accessibility, to audit, for example, you want that to be rendered and attached to be able to run the entire suite of tests. So you can get help in your applications by testing with an API. And there's multiple APIs out there, but the goal of most of these is to save you from the boilerplate of having to write tests for things like label and name computation. So you shouldn't have to be an expert in which item takes precedence and like knowing all of the support across platforms. That's a lot of insider knowledge to have to hold on to for every project. Incorrect ARIA usage. In your unit tests, you wouldn't want to have to write a test to make sure that someone's not using a widget role, or an abstract role, or using the wrong combination or whatever. That can be a lot to try and bottle into your app. So if you use an API, that would help. Color contrast, which is a really computationally expensive calculation to make, and there's a lot of edge cases that we have to constantly try and improve testing for color contrast. Determining if a table is a data table or a layout table, those can be some tricky rules. And then viewport or zooming problems. So these are all things that we should test for, but if you had to write all of these tests yourself, I mean, that could be your full-time job. That is my full-time job. So we don't want to have to do that for every single app. So that's where something like aXe-Core can be really helpful. aXe-Core is an engine for testing accessibility, and you can find it on NPM and GitHub. aXe-Core is an open source JavaScript library, so it means that you can use it for free in your applications. There's no network or API key required, which I really like because sometimes I fly on airplanes and I don't want to pay for Wi-Fi. But I could test with aXe-Core on something locally and have it return results to me. And for some companies, you can't have your code grow legs and go out over the network to someone else's server. It just doesn't work at some companies. aXe-Core is configurable. You can configure the rules and checks to override them, to write your own. You can turn individual rules on and off. We aim for no false positives, and that means that we're only reporting on things that are actually useful to you, because a tool, it kind of degrades in usefulness if it's not reporting things that mean something. And if you find a bug, please come find us on GitHub, because we always want to make these rules better, and there's so many ways to build websites that, as you can imagine, it takes time to fix bugs and things. So we'd love your feedback if you find a false positive. And then, as I mentioned earlier, we're really deeply involved with standards. We want our rules to be repeatable and rooted in standards, so that's something that we work on as well. So to write a unit test with aXe-Core, you would go and grab it from NPM or pull it into your fixture somehow, and then you can use this API to assert that there are no accessibility violations. And I'll show you what the results object looks like in a minute. But using the axe.run API method, you can pass it a selector as a string or an element reference. It defaults to the document, but you can imagine you can sort of scope it to whatever element or component you're testing. You can pass it any number of options. And then this callback function takes an error parameter and a results. And the error will bubble up errors, as you might guess. And then the results object it's a JSON object that contains violations, passes, incomplete, and inapplicable. And so you can start to assert things based on what that returns from whatever you've tested. So in this test, I'm expecting that there are no violations because we don't want any accessibility violations. There is a WebDriver library for axe-core that you can use called aXe-WebdriverJS, and it's available on NPM as well. So in this test, an integration test, I'm pulling in aXe-WebdriverJS and Selenium WebDriver, and then I have some global dependencies in this example that I'm not really showing, like Jasmine. But once you've set up WebDriver, you can tell it which browser you want to use. So you could fire up Firefox or Chrome, depending on which driver you have installed on your machine. And then you can go tell it to hit any local or remote URL. And once that promise is returned, you can say axe builder, pass it the driver, and say analyze. And it will return that same results object to you. So you can start to use the same results in these different scenarios, which is nice for that kind of consistency and stability. We have another new tool that I wanted to mention, which is aXe-CLI. So you can get a bit closer to the metal and get away from some of these dependencies like Selenium in your test itself by installing aXe-CLI globally, and then you can call it from the command line. You can tell it to go to one URL or multiple, they're comma separated, and then you can pass all these options. So you can scope it using the include or exclude. You can pass a browser flag for whichever browser, assuming you have the driver for it. You can turn rules on and off, and then you can save the JSON that it outputs, which is really cool. So the output in axe-core is a JSON structure. So as I mentioned, it includes violations, passes, incomplete, and inapplicable. And I'm zeroed in on the violations here. So I think my tests, I usually will just console log the violations when I'm debugging to see what's going on. So there's things like buttons have discernible text, the contrast between the foreground and background colors for a given element, ensures every ID attribute is unique so that forms and screen readers can take advantage. The non-empty title attribute on an iframe, the laying attribute on an HTML document, image elements with alternative text, like they're missing alt text, form labels and stuff like that. So that's a lot of tests that you didn't have to write, which I think is really great. And you can find our entire API on GitHub. So that brings us to continuous integration. So we couldn't really talk about continuous integration until we talked about what we were going to test. It's kind of an important thing. So the idea with continuous integration is that you're sending code to either a new environment or you're maybe merging branches together after someone has done a PR for a new feature or something, and that when this code is merged together, it's going to automatically run your tests and then report back to you whether it passed or failed. Some common solutions for continuous integration, at least in the front-end space, are Circle CI, Travis CI, and Jenkins. And today we're going to focus on these first two of Circle and Travis because they're hosted and, frankly, much easier to work with. So hosted CI, in a nutshell, the steps go like this. You write your code and write your tests, our meta coffee table book of coffee tables scenario. And get those tests, and they could even be passing or failing. You just want some sort of a test to run when you hook up this CI. So you enable an integration to a Git repository, and I'll show you those steps. Then you go on to the hosted CI, either Travis or Circle, and enable CI builds for the project. And then when you push code, it will automatically run them. And it's so easy. I love it. Here's an example of how we use CI. On axe-core, we have Circle. We've used Travis as well and Jenkins, but Circle has a great integration for GitHub so that every time we push a commit, it will automatically run all of our tests. So for pull requests, that's super awesome because every contributor, we don't have to manually check out their code and go run the test. It'll just do it on that machine. So you can go and see what tests failed. You can see if the build's passing, and that peace of mind is just awesome. So you have to configure Circle. So it has defaults, but if you have a circle.yaml file, that will override the defaults. So the things that we commonly reconfigure are the version of Node.js, because the default is kind of old, and we like to use newer features for JavaScript, especially in our tests. So you can configure that. You could configure deploying, like all kinds of things, and the Circle CI docs cover all of that. The Travis version is very similar. It just has slight little syntactical differences, but to override Node.js, this is the syntax you would use, and the Travis docs also have similar suggestions for things you could do. So CI can really help for accessibility because it expands your reach onto more platforms. So say you're developing on a Mac and you could hook up CI with Sauce Labs or something to go and test on Windows. Or test some mobile device or some browser that maybe another version of a browser. It really gives that opportunity to automate testing in more places and more platforms. The biggest thing, I think, is that you can prevent regressions. So if you've got test coverage and you worked on this awesome feature and you made it totally accessible and then someone new came onto the team, or maybe even you 4 weeks later, and you break it, because maybe you didn't know that that's how it was supposed to work. So by having test coverage, you know when it got broken, hopefully. That's the goal. So that when things are getting merged, you're not just breaking stuff and not realizing it. And it really just encourages test coverage because you're having this goal of making sure you're not breaking things, and when you do break things, that's a good sign that you needed a test. Sort of a fail-driven development. So here's an example of hooking up CI on GitHub. I have a repo for using axe core with Jasmine, a little unit testing example. So I had a unit test already. I just went onto my repository. Actually, I have the project checked out on my machine, and so in my IDE, I open up package.json, and I have a npm script for npm test, and it just runs grunt and Jasmine and runs this test. In my Jasmine test, it's pointing to axe.js, which I have included as a dependency, and then I tell it where my tests are. In this case, they're in a spec directory, and it just goes and looks for any JavaScript file and will run that test. So in the test, I'm pulling in a little string of HTML. Now, the way you include a component, like there's so many different ways. You could be requiring it, you could be loading it somehow. In this case, I just sort of hard-coded a little snippet, but how you configure that, it'll depend. But once you've got some reference to some HTML, this is appending it using Jasmine. I can then go and grab that element using document.getElementById and use axe.run on it. I pass it the reference to the element I want to check. I'm just leaving the default options by passing an empty object, and then that callback function will give me that result object, and I can assert that there were no accessibility issues for that individual component. So then over on GitHub, if you go, the caveat is that you have to have permissions to actually get the settings on this project. But once you do, if it's a side project or you have ownership of this repo, you go into settings and then integrations and services, and they have a whole list of services. They have both Circle and Travis. So I can enable Circle. I just hit the default. I didn't add a domain or really do anything. I just hit add service. And then it's there. I can go and check services, and it'll list everything you have integrated with that repository. Then I go over to Circle, authenticate with GitHub. I go and find this project, and I just say build project. And it sort of makes that connection between GitHub and Circle to be like, okay, you have permission, Circle, you can go build this. And then I can either trigger a build manually in Circle right there, or the next time I write a commit, depending on how you have it configured, but the default is the next time you commit, it'll just run your tests, which is awesome. Like really low friction, really easy. And the goal is to get all green, get these all successes or fixed, so that if something is broken, you know about it, and you're like, oh man, I gotta go fix that. It's awesome. So there's some gotchas that I wanted to call out. Things that I've discovered from working with CI that were kind of a pain, and they're just things that we have to work around. So if you see a syntax error, unexpected token, ... and it says error, The issue commonly is that you have too old of a Node.js version. So you might need to reconfigure Circle. As I mentioned, Circle and Travis both default to old versions of Node. And if you're trying to use something like a spread operator, spread syntax in ES6, you need a newer version of Node for your tests. If you see type error undefined as not an object for some piece of your code, maybe a clue is like, what feature did I just add? And I can look at what it was trying to evaluate and go, oh, yeah, that code I wrote is not working in CI for whatever reason. If you see that, try to reproduce it locally first. The trickier bugs will pass locally, but then not in CI. So you want to make sure that it's not happening locally first. So run your tests there, and then in CI, try and get a clue as to what it is, what is undefined. But if you can't figure it out, here's some tips. If you're using Mocha, there is an option for logging errors. Turn that on, because it will actually display the errors in the CI. So you can go and look at what it was, because otherwise it'll suppress them, depending on which testing tool you're using. And then as a last-ditch effort, you can wrap that failing code in a try-catch block, and then just explicitly log that error. That is like such a useful tool. It's a little bit hacky, but if you're not getting errors and you're wondering why, you can just try manually logging it, and that's one tool that you could try and use. So something I thought was really great, I asked on Twitter if anybody had a build status monitor to try and gamify CI builds, to make it more of a cultural thing and kind of like, oh man, I broke the build, because I did that with Angular once, and I happened to be in Mountain View and see my name up on the big screen that I broke Angular, and it was mortifying. So this company, Talus, they have this Western-themed build status monitor that shows who broke things, and it'll say a reward of $60 for crimes against some app that they'd written. My favorite was an older version that said for crimes against Babel, which is awesome. So you could do that. You could use CI and use these builds. I mean, I'm looking at it, so this screen is on Circle, but you could take that API and display it on a monitor in your office. It could be like a piece of artwork, interactive artwork. You could light up a light over someone's desk or fly a drone in your office. And there's like so many fun ideas that you could use this. So that's a really cool idea. So the goal is to get those tests passing. So you're like, yes, it's all green, it's all fixed. We did our work, we have test coverage for accessibility, and everyone's happy. So to recap, we can automate about 30 to 50% of accessibility issues depending on your rule set. By writing a mix of unit and integration tests, we can hopefully prevent failures when things are actually integrated in these real environments. You can expand your platform coverage with CI so that you have more like eyes in more places. But beware of gotchas when you're chasing down errors. I'd say that's the biggest thing I've learned about CI was like how to handle these errors and how to figure out what was actually failing. So it's a bit of an investigation sometimes to find that out. But then don't forget about usability and manual accessibility testing, because that's like, this is just the start. But it's a really good start, and you can get accessibility in your workflow now. So thanks so much for listening. I'm Marcy Sutton. You can find me on Twitter and GitHub. And we've got about 2 minutes on my timer, so if anyone has a question, otherwise you can find me in the hallway track after. Any questions?